principal of the Sakha Junior Science Academy, which is the government organization for the gifted children. So we have today very distinguished guest, Dr. Ivahara-san from Fairbanks University, which is in Alaska, and Miyamoto-san from the Hokkaido University, okay? And the topic of the day is the permafrost. And permafrost is the most important topic for us in Yakutia because the city of Yakutsk stands on permafrost. It's 1,500 meters or 300 meters of frozen ground at the knees of this town. And in 1964, here was only 40,000 people, population of Yakutsk. Now it's more than 300,000, 370,000 inhabitants of this city, and it's growing. You are from Fairbanks, and is there any, you can tell us about your studies, your research, because it will be very interesting. And in the end, I would like to ask you to answer me one question. What is the optimal size for a town in the permafrost area? Is it normal to have a big, very big city like Yakutsk on the permafrost, or is it dangerous? Okay, so please, you can, do you have any presentation so we can put on the presentation, or you can just talk?
I can do both.
Okay, so they have a presentation, please. Yeah.
I didn't know about the topic of today,
but about your research anyway.
About my research?
Yes,
yeah,
exactly. Yeah. Okay.
So my name is Go Ivahara, and I was born in western part of Japan, near Osaka, Kobe, around there, which is just a seasonally frozen ground area. And then I moved up to north, Sapporo, and I entered my college in Hokkaido University when I was 18 years old. And then in my university, I majored in geophysics, and under hydrology department, I started to study about frozen ground. Because so how I can use this? So this is, yeah, this is a. Yeah, so I showed on the map, the background map is a distribution of permafrost. So you can see Yakutsk is in the middle of continuous permafrost region. And Hokkaido, Sapporo, there is a little tiny island of isolated permafrost. This is we have also permafrost on top of mountains in Sapporo, Hokkaido. Here. Yeah, one small spot. And we have also permafrost on top of Mount Fuji. Yeah. So in Sapporo, I studied about frozen ground, but it's seasonally frozen ground because it damages automobile roads and railroads and houses because of the frost heaving. So this is a kind of civil engineering or just a fundamental physics problem. And then when I was doing a PhD work, master coursework, I've been studying in Yakutsk I started to study about permafrost now. And the theme was influence of forest cut over. So forest harvest, deforestation, or forest fire on permafrost. So that was my thesis theme. And then after working several years in Hokkaido University, I moved to Fairbanks. And I started to work as a postdoc. And now I'm doing an assistant professorship. And because I as a permafrost scientist, it's really need to compare Siberian permafrost and Alaskan permafrost. So, yeah, so this is a institute of my job, International Arctic Research Center, located in Fairbanks, and came from there. This is Yakuza. Oh, this is animation. Next. So I don't know how many minutes I have. Yeah. So this is the start of my study about frozen ground. So this is a needle ice. In Russian, it's a stabilikovый лед. And in my hometown in Osaka, we in the morning of cold winter, we often observe this kind of ice on the ground, and children are stomping around and playing on those ice. So this ice is a first formation of ground ice because of the seasonally frozen ground. And usually people don't know how this needle ice formed, grow. So this is not from the atmospheric vapor. This is not like a frost, but this is a ice formation by migration of ground soil moisture into the freezing front, and then making ice lenses. So we can observe this in the mid-latitude when the frost is not so heavy, like here. So in this town, it's, I think, have you ever seen this kind of ice? No, because the frost is so strong. So to make this kind of ice lens, we need a very, very slow freezing. Yeah. And I started to study about this needle ice formation. So if the freezing front penetrated into the ground, you will see the needle ice in the ground. And I studied about how this needle ice forms in the ground. So I skipped this. So this is a very, very old photo in Sapporo back in 1940s. And you can see the heave on the ground. Yeah, and it damages every infrastructure, even in Sapporo, entire Hokkaido and northern Japan too. So this is a big problem for local people. So we study about this and how to prevent from this kind of heaving. So this is very related. So, and then I started to learn about permafrost in Siberia. Because of the very, very strong freeze, the freezing front penetrate into the ground and make many, many ice lenses like this, if you core it. And I am analyzing this physically and chemically, geochemically. So this is the summit of Mount Fuji. And we drilled into the ground, and we also found this kind of negative temperature all year around. And so this is the permafrost layer. It continued down more than 10 meters. We don't know the end of the bottom. So as you can see, the pore could be, several 10, 20 meters. And every core was filled by ice. So now I switch the topic to the permafrost in Siberia and Alaska. So this is the green area is the distribution of a very specific permafrost deposit called Yedoma. Probably you know the Yedoma ice, this sediment distributed in most of the central Yakutia and northeastern Siberia and the north of Alaska. And this deposit contains a lot of ground ice. It's up to 95% of the volume. So this is sometimes looks like this. Yeah. Yeah. Yeah, so this is a human standing here. So because of this high volumetric ice content, when this permafrost thaw and ground ice melted, the ground will deform. And the ground, you can observe in the villages, this is a thermokarst. So my topic is about this, so thermokarst. So here is the ground ice, and this is a seasonally frozen ground. And when the surface was disturbed by fire or clear cutting or some vehicle road, then the ground will thaw, the permafrost will thaw, and the ground surface will deform like this, and the carbon contained in permafrost will be freed. Some portion of greenhouse gases will release into the atmosphere, and some organic matter will be freed to be decomposed by microbes. Yeah, methane, carbon dioxide. So depending on the condition. So we don't know how this permafrost thaw influence on global carbon cycle and how much this contribute to the increased temperature or something. So we need to identify how quickly we are losing permafrost and ground ice. Then we need to know how much greenhouse gases were fixed in the frozen ground and how much carbon was there. And then we can calculate how quickly the carbon was emitted from the permafrost. So this is an entire purpose of our study. So we sample this ground ice and analyze about greenhouse gas content and geochemistry of water and sediment and age of the permafrost. So this is one portion of my work. And so this is from ground ice analysis. We are trying to reconstruct the paleo environmental history. So this is another, from Pleistocene, Holocene, And the next portion of my work is to identify the rate of permafrost loss. So how quickly the ground ice was losing. So this is one method looking from the sky, from the satellite, how the ground surface is deforming. So this technique was initially developed to monitor this kind of a volcano eruption. So when volcano erupts, it deforms, it dilates or some. So using this satellite micro electromagnetic wave, we can identify the distance between satellite and ground surface. So this is a little bit the mechanism, how we can identify that change in the ground surface. So in short, we use an electromagnetic wave, and we observe the same spot at different time. And the maker calculate the difference between two observations. And we will know the shift in the phase of the wave. And then we will identify centimeter, millimeter difference in this time period. So it's kilometers, 10 kilometers, 10 kilometers. So this is an example of your land. This is a Maya village. You can see this is a town of Maya, and here is a open area. So this is the abundant crop field, and this is active crop field. And if we analyze the data, you can see this kind of distribution. So green area is stable. It didn't move. But comparing to this stable area, we can identify some few centimeter, 2 to 4 centimeter per year subsidence in this case. Yeah, going down. And if we compare with this optical image and insert image, so open, especially open area is sinking. And if we look at different year period, you see the different spatial distribution of this subsidence. Speed and area. So this is very, very useful tool. So now we are looking at Batagai area. Here is a Batagaika. And they experienced huge wildfire recent year in 2018 and 19. Here it's too dark. But this was a bond here. So we know this land is very, very ice rich. So if we got some disturbance, surface disturbance like fire, then maybe it will trigger another Batagaika. Yeah. Yes, it's a very thick ice-rich permafrost. So after the fire, we see again the subsidence signal with the inside of the fire. Outside of the fire, we see the stable, but the fire impacted the permafrost and it started to solve. But in this case, this subsidence signal taper down and it seems like a recovering. So not always we see the thermocals. The nature itself has a resilience against disturbance. So we shouldn't worry too much. So, probably this is and this is my contact information. I just prepared for.
Just a question. Is there any studies concerning the surface of city of Irkutsk, of this city? Does any people do any studies from the space, from the satellite?
Yeah, we are looking at this area too, okay. But very, very little deformation.
Very
little, but some area has some subsidence, but this is not because of the thawing permafrost. Mm-hmm. Because permafrost in here doesn't contain a lot of ground ice, right? This is very close to the river.
Yes.
And this deposit doesn't contain like Yaduma.
Okay. So this is basically frozen, just a frozen ground without much ice.
No.
Yeah. Okay.
So if there is a deformation, probably this is because of another reason.
So some people very much afraid that everything may subside in Irkutsk because there are some buildings already suffered some structural damage recently. Is there any predictions that it may happen in several years' time with the many buildings in Irkutsk?
Not because of the ground ice melting, but if you make some landfill area will subside.
Okay.
This is often happen in every city in the world.
Okay, okay, yes.
So yeah, if you newly
Mhm.
put the ground,
Mhm,
make the flat area,
mhm.
the land will subside.
Okay.
And from by using this kind of method, you can monitor
Mhm,
the rate of subsidence. And
mhm.
I hope this method is helpful for future planning
Okay,
or
future planning for the
management.
for example, this is a very interesting situation.
Mhm.
On a permafrost area, we
Yeah.
have a city like Yakutsk, and it's grown in size. It's a very big city in the permafrost area. Yeah, and the importance. I'm just wondering, is there how much of the influence the anthropological factor can make in changing the permafrost situation in total? For example, every house in Yakutsk heats up the ground. There are so many cars going around. And as you said, because of the lack of Yedoma-like ice, the city of Yakutsk may still continue on standing.
Yes, but even though there was no such a big ground ice, but thawing of permafrost itself, the make unstable the foundation of buildings.
Right.
That's true. So if the increase in temperature and increase in seasonally thawing layer,
Right.
active layer thickness will make the foundation unstable.
Okay.
So that, but I am not an engineer of the building, so I cannot answer directly to that question.
Okay. So if any of you have any questions to Professor Ivahara? Yes, no questions?
So there are many, not many, but currently I'm using a Japanese satellite called ALOS-2. Yeah, ALOS-2, which is a microwave satellite. And European Space Agency has Sentinel-1. So both using microwave, so very long wave satellite sensor. So we can use these two basically. And there are another commercially available data. And next year or 2 years later, NASA will launch another ALOS-2 kinds of satellite, and data will be delivered for free for everybody. So everybody can use it. So, but you just need to know how to
Use it.
analyze it.
Okay.
Yeah.
Okay. Because this is very high up, there are very few satellites because it's so difficult to put a satellite on higher up areas, like because there are not many people anyway, and it's economically not viable, I think, only for some specific research. Yeah.
Not for specific research. It's for monitoring of
disasters. Okay.
Yeah, because in Japan we have a lot of disasters like volcano, earthquakes, and flooding, tsunami.
Yeah.
That's why Japan launched this one, and especially looking at Japan, but it is
also
cycling around the Earth.
Yes, yeah.
So
okay. So
we can use everywhere.
Okay. Thank you very much, Professor Ivahara. So thank you very much. Yes. So I have another guest who is actually directly from Japan, Dr. Yamamoto-san, and she's from the Hokkaido University. Hokkaido is the nearest and the biggest province of Japan. Is a prefecture or province of Japan? Yes, and this is the northern part of Japan. So I would like to give the floor to Dr. Yamamoto-san to talk about her research, and she has a presentation. Her presentation. So you have been visiting Yakutsk many times.
Yeah, more than 20 years.
More than 20.
From my graduate school.
Graduate school. Okay. So the things change a lot. Okay. Because have you been to many villages around, and there's many lakes appeared? I noticed as well. Yeah.
I thought this is more stable,
Uh-huh.
but during these
20 years is gone.
I witnessed.
Uh-huh. Especially in the north.
Yeah.
So many changes. The ground gone very deep down in many areas. Yes. Amazing. How dangerous it is, to have a release of the carbon dioxide and methane, in your view, from the melting of the permafrost?
In terms of carbon budget,
Mhm.
I don't think it's not too dangerous.
Okay, for the world.
Because it's slow process.
Okay.
That's my opinion.
Okay. Thank you.
Okay, thank you very much for the opportunity to talk today. And my name is Юмико Miyamato. I now work at Arctic Research Center at Hokkaido University. And I started working in Yakutia like about 6 years ago. So this is kind of new area for me. And my background is forest ecology. So I'm doing some research in different countries, including Japan, Siberia, Canada, and also tropical areas. So today, I briefly introduce my research activities, what I visited and what I have done. So before I talk about my research activities, I want to talk about about the importance of a global forest and my motivation of my research. So this map showing the global forest distributions, and Russia has the largest forested areas, like 800 million hectares. And second is Brazil, and third and fourth is Canada and the United States. So these countries have large territories. So that's why forested areas are high. So I'm from Japan. So Japan is a small island country. So we have a small forested areas. But when you see the percent of land area, nearly 70% of land is covered by forest. And this value is actually bigger than these countries. So Japan is very forested. So this is the map of Japan. And as you can see, these are all covered by forest and looking all green. So we have a high land area, it's covered by forest. And forests are also important. We also have 4 distinct seasons. So Japan is located in temperate regions, and we have a lot of rain. So we have beautiful spring flowers and also autumn colors. And some part we have snowfall. So this area is very beautiful. And forest is also important for people living in Japan. So many houses are built by woods, and used to, until like 1960s, we have woods for fuel. And all books and furniture are built by woods. And we also have like food products from forest, like mushrooms and herbs. So using forest is very, forest products and are very important for our life. But now at the global perspective, like forests face many challenges. Like 2 big impacts are human impact and environmental changes. And human impact include logging, and people cut and use wood product, and also the land change. So land change is mostly like people destroy forest and change to different purposes. So it's different from logging. usually logging people harvest, but also plant and make cycling for timber use. And another big issue is environmental change, like climate change, including drought, extreme weather, and climate change also affect forest fire frequencies and insect outbreaks. So there are many issues we need to think, and we need to understand how forests respond to climate change, environmental changes, and also we need to understand how to manage forest in sustainable ways. So that's my motivation of studying forest ecology. So I have done some work in different countries. So first, I got a master's degree in forestry and studied in Western Canada about climate change effect on tree growth. Pardon me? British Columbia. Yeah, British Columbia and also Yukon. Then I got a PhD in Japan about a study on plant and fungal associations. And I talk about these activities in this presentation. And currently work in Siberia, and also previous work, I worked in tropic areas. So first I want to talk about Canada, I think. Yes, so this is British Columbia, and my research also extends to Yukon areas. So in British Columbia, like forestry activities are very popular, and large areas used for timber production. So research about forestry and forest research is very active. So these are some pictures, and you can see many patches of cut from the air and everywhere. And this is the large patches, and there are some experimental studies of changing sizes of forest patches. So here, my study is to understand how trees respond to climate change. So I used tree ring analysis and compared tree growth in different places. So this is the climate condition in 2005, but in 50 years later, they predicted climate. It's like this. So the climate change will affect tree growth. So in my study, we found that like trees growing in higher elevation can grow better in the future climate, but at lower elevation, it's get drier and tree growth may be depressed. So if you want to maintain productivity in the future, we can suggest that to plant trees in higher elevations. So this is my research in master's program. So when you see forest, mostly we generally see the above ground, but below ground is also important, and all water cycles and carbon and nutrient all cycles. So now I'm currently focusing on the below ground processes and looking at tree growth and microbes and the interaction between plants and fungi, microbes. So actually all trees are associated with fungi. So without fungal association, plants, a tree grow poorly, but with fungi, plants often grow well. So this So the mechanism of this association is fungi, like mushrooms, take up carbon from trees, but also these fungi provide water and nutrient more effectively to trees. So it's enhanced tree growth. So this is a very important association for tree growth. So this is called mycorrhizal symbiotic association. So both tree and mushroom fungi gets benefit. So this is a win-win association. So every tree has this kind of association. So I started to study these fungal and plant associations. In Japan, oh, okay. So you can see many mushrooms in the woods. So there are high diversity of mushrooms and fungi. So I studied the diversity of fungi and did my PhD work in Japan. So all over the Japan, we have high mountains, and Japan is located from south to north. So there are subtropical area to subboreal forest, also temperate forest. So our research team did some survey from south to north. Then we analyzed tree and fungal associations at different scales, like local scale and also regional scale. And we found that there are high fungal diversity at colder site. So which means the increasing temperature in the future may affect these diversity patterns. And also many mushrooms and fungal species are affected by warming, even they grow in the soil. And currently, I also studied using Saha flux network stations and to study the diversity of mycorrhizal fungi. And these are some of the Saha flux network stations that were maintained by IBPC. And this some survey and saw the global pattern. So from Japan and also Indonesia and Siberia. So the diversity is highest at about 0 to 5 degrees Celsius. But in Siberia, the diversity of fungi is still high compared to tropic areas. So I also use DNA analysis. So we have many technologies of DNA now. And we discovered a new fungal species in Siberia. So we compared databases, and these are already known species. And we found a species in Siberia, and this species is different from any other known species. So it turned out to be a new species, and it's a ground mushroom. So we named this species Rhizopogon radicinus. And this is a ground mushroom and also associated with larch, specifically associated with larch. And this species is often associated with pine and tsudotsuga and different pinaceous trees. But this is a first field confirmation of this genus associated with larch. So this is very important. And this is found from Yakutsk to Chokolda in the Arctic side. Okay, and now, currently, I was in Chokolda a few days ago, and I just came back. So Chokolda is located at tree line. So in the south, there's a tiger, and when you go to north, the tree population decrease, and tree height is also decreased and turned out to tundra. But under warming, trees migrate, so tree lines will extend to northern areas. But when tree distribution expand, associated fungi also need to expand. So I'm now studying the availability of fungi and tree seed in tundra and started some work of these associations. So this is a current work I'm working on. Next. And also before COVID, I just started working with some researchers in the Russian Far East and did some research in the effect of forest fire on the ground microbes. And there's a permanent plot after in the burned site, and I compared the burned site and unburned site. So we just started a collaborative study of forest fire research. So these are the study I have doing in Siberia. And before I get this position, I also worked in tropics. So I briefly want to explain about tropical areas. So this is also the forest fire site. So forest fire is a global issue and occurring from tropics to Siberia and northern boreal forest. And this is a forest fire site in Indonesia, in Borneo. And this is a forest 15 years after fire. So actually, before, so in the Russian fires, this is 16 years after forest fire. So, but in the tropics, the forest recovery is very quick and trees grow very fast. And this is an international project on forest recovery in tropical regions. So we did some field survey and also did some experimental work in greenhouse. And this is a research institute in Indonesia, and also Japanese government also helped to fund this research center. And this is some picture of tropical areas. So you can find big tall trees, and it's called buttress root. And plant diversity is very high. So these are example. This is an example of carnivorous plant, and this is a seed, a very spike seed, very big seed, and also spiky. So you don't want to touch. So you can find many unique things in tropical regions. So I think this is the end of my talk, and I visited from tropics and northern boreal forest, and it's very fun to visit. But the important thing is we live in the era of global environmental change and globalization. So many people and things move all over the globe, and global processes are affecting local processes, and local processes also affect global processes. So we need to have some both global and local perspectives. That's what I'm thinking. This is the end of my talk, I think. Okay, and thank you very much for the opportunity for this talk.
So much. It's beautiful story about the forest, about the fungi, about all these differences, biodiversity that we have more in colder areas. So the colder areas may have very high biodiversity, especially in fungi, as far as the fungi are concerned, which is very interesting for Yakushin researchers, I think. Yeah, we can find new fungi if we research more, and there's lots of scope for research, especially when you use the DNA analysis and so on, which is very actively pursued by the scientists all over the world nowadays. And Dr. Yamamoto-san, if you have any question, ladies, no? Okay. So the most important things in our view, you see, because of all these difficulties of getting recovery, the forest recovery after all the fires, etc. And you have shown that biodiversity drops after the forest fires, etc. So what is the, because your research is only 6 years, the span for the research, which is you cannot say what is the recovery time for all these forest areas to recover their full biodiversity, etc. in Yakutia. Is it like that, or you have some projections how fast this process can happen?
Some forests, like in Siberia and North America, forests are adapted to forest fire. So there are some mechanisms of recovery. Also, fungi and trees can recover in these ecosystems, such as some pine open pine cones with heat. So they can regenerate after fire. So fire is an important part of forest regeneration. And also some fungi have spores that have a tolerance to heat. So they can survive below ground and quickly associate with trees. So these systems are, so trees and all organisms, plants are adapted to fire ecosystems. So recovery can be quick, but the big issue is frequency and the intensity of forest fire is increasing. So that's a big issue.
As far as I understand from your talk, most of the forest fires can be beneficial.
I think it's beneficial for some plants adapted in these ecosystems.
So we can, in fact, suggest that these forest fires may have happened long time ago in Siberia, and it was beneficial for some times because for the forest rejuvenation. Yes, and in fact, it can even help forests to clean all the debris and everything, and then start to grow again.
Yes, this is a natural cycle.
Natural
forest
cycles.
Fire is a natural process, but the extreme weather and now very large area is burned, and also fire intensity is increasing, and some plants and fungi may not adapt to this extreme conditions.
Okay.
So we don't know much about how this high frequency and intensity and extreme conditions affect biology in these areas.
Okay.
So that's a new area for study, research in the future.
Okay. So finally, I would like to ask questions from Professor Ivahara-san. What, for example, is there any possibility for the Yakutian students to do some research even in Fairbanks and so on? Do you have any joint programs for research with the scientists in Yakutia and in the United States? Is there any possibility of joining, for example, these ladies may start the education at the local university here with the prospect of getting into the permafrost studies and so on? Do they have any possibility of getting some joint program research in Alaska or in areas that your center is actually active?
Yeah, recent years, we have a lot of opportunity for students giving a summer schools. And University of Alaska Fairbanks also offering a lot kinds of summer school and gathering students from all over the world. That is a good start. And for example, there is a Belmonte Forum. This is an international research project, and joining from multiple countries. Currently, I have one project, including United States, Japan, France, and Russia, and studying about permafrost thaw impact on the soil. So this kind of international project will asking some help from students. So joining this kind of international project is one thing. And I also think Japan has a joint program with Russia, so we can submit some proposal jointly, and including some student salary. So there is an opportunity like that. Yeah.
Miyamoto-san, is it possible to tell us about the possibilities of, for example, doing some studies at the University of Hokkaido? Is it any possibility of Yakushian students come to Hokkaido to study and study this type of topics like forest and so on?
Yes, we have many opportunities, and actually, every year, students from NEFU come to Hokkaido University, and we have joint master program. And even this year, 2 students doing the degree program, but it started like a few years ago, and this is one opportunity. And also I work at Arctic Research Center. We have a joint research laboratory. This is a research and education activity agreement between Arctic Research Center and IBPC and NEFU. So, and there are many, some opportunities and also some funding funding. So if students want to study about Yakutia and also in Japan, you can apply.
So thank you very much. It was absolutely wonderful to talk to you, both of you, because we are going to put your talks on our YouTube channel, because this is for the children of Yakutia and Russia. They're usually interested in what research is done around here and other places and how the scientists work and so on. And if you have any suggestions, how to get into your areas of research, you see, for example.
Yes, I wanted to add one information for students who are willing to study some topic like in United States or Europe or Japan. I suggest students to write a very good proposal, very concrete theme of your interest. For example, permafrost related, and based on your major. If you have a very, very concrete theme, and then you should submit your proposal to professors based in other country you want to study. And then professor can include student salary and tuitions, everything in the research proposal. Then they can hire them and start joint program. This is a usual process in, for example, in United States. In Japan, maybe different process. But the researchers or professors in United States, they want concrete proposal from student. Then if the interest of professors and student matches, then it's very easy to proceed.
A very sensible way of doing things. Yeah.
Of course, it's better to have some contact
Okay. Yeah.
from known professor introduced to other professors. That's very strong.
Yes, it's a strong way.
Strong way.
Yeah, to do things. Okay. So you have heard. So this is, you can take on your note and may use it in the future. So thank you very much, Professor Ivahara. Thank you very much, Yamamoto-san. So thank you for all coming here. And I would like to thank Roman for bringing our guest and Yamamoto-san. I think, Roman, you're also doing some research in Permafrost or what? Okay. Okay. And you did study in Norway or somewhere? Oh, Stalwart. Yeah, okay. Okay, excellent. So you have many opportunities, you see, nowadays to do whatever you have interest in and expand it and use all the opportunities that lie in our neighboring countries like the United States and Japan. And they have a very good academic traditions. We can be utilized for your future development. So thank you very much. And I would like to wish you all the best for your research, and do always come and if we ask you to come and talk to us, it will be extremely good in the future, you see, because we might have more questions, you see. Yes. So thank you very much again. So that's it. Maybe we can take a shift. Okay, we start here and then we'll take a picture. Okay. Or maybe here, yes. We can stand there and then we can take a joint.